Hello everyone and welcome to 14th lectures of digital image processing of remote sensing data. It's a completely different topic. So far we have not touched anything about this, but this is very much required in remote sensing and digital image processing because when you start working for a real project, the database becomes very huge, because these images with high spatial resolution occupy a lot of space on your hard disk, and therefore we have to find some ways so that we can manage our hard disk space and also can perform digital image processing efficiently. And for that there are techniques which are called the image compression techniques. The very common one, which is not a truly image processing technique, but is a data compression techniques which most of us are familiar, like WinZip or RZip, which compresses or try to compress everything for you. But how these compression techniques works, which are the types of compressions techniques, fundamental compression techniques are available, which are the compression techniques which are though available to some extent, but they are copyright protected and so on and so forth. So we will see many of these compression techniques, the basic one, and then different image formats. Some of them itself are compression formats. So we will see one by one all these. So let's start with this, that as we know that the image is a two-dimensional metric. It is stored in terms of rows and columns, and you are having the cell value here is the digital number. So it we call as a pixel. So this unit we also know that the unit, that is the pixel, is always square in shape. So data is in digital image processing can be classified as continuous. Our images are continuous, or sometimes you have to handle the thematic, which may be in that sense they are also continuous, but in between you don't have many details. But here in case of image, for every pixel you are having detail, and there are various data formats, image data formats, which we know we handle in digital image processing, or even with our digital cameras or mobile cameras, like TIFF, GIF format, JPEG format. ADAS is a well-known image processing system, so ADAS is having its own format, which is called IMG format. So there are nowadays various hundreds of image format exist. Every format is having some advantages, and there are always some demerits associated with each format. So few which are common in our digital image processing parlance, we will use that one or discuss on them very much. Before I go for individual or for basic data compression techniques, I would like to take an example which is very simple one, and we start to understand the data compression and nitty-gritty of data compression. We will start with a very simple example and are going to take a binary image. Only for our understanding, these lines are shown here, but actually in the true image there are no lines, only pixel values or digital numbers are in a two-dimensional matrix. So this is binary image. That means here we are having a shaded area, and rest is just white area. So there are only 0 and 1 scenario is there. That is why it's a binary image. Data compression, that for understanding we will look the binary, but of course on colored images also, or 8-bit images, any bit images, the data compression can also be performed. So let's go for the first technique, which is called chain code technique, and in this one, the boundary of the region. So here this is what we will try, that the area which is out of white and black, which is the area which is smaller, on which the boundary is recorded basically. This is the boundary of this shaded area. So the boundary of a region can be given in terms of its origin and a sequence of unit vectors in the cardinal direction. Cardinal direction means north, south, east, west directions, and these directions we can code them give some number, like in this example we are giving for east direction, we are giving 0, for north direction is anti-clockwise, so we are giving east 0, north 1, west 2 and south 3. So these are just simple codes. One can, while writing a program, one can change this codes, there is no problem. But just for our understanding, anti-clockwise and starting from east, starting from 0 value to 3 value are coded. And this example we start at row 10. Row 10 is this one, because on the extreme left, that is the column 1, row 10 is the first pixel which has to be coded, or boundary of this one has to be recorded. So we start with row 10 column 1, and the boundary of the region is coded clockwise by that. So though the codes are anti-clockwise, but the boundary will be coded clockwise. So this is how, if we coded, this is not arithmetic that one can argue about, that how 0 can have power 2. These are just codes. So assume not a numeric value but codes here. And so that if we say that 0, that means 1 pixel towards the east, because for east we have given 0 code, for north we have given code 1. So that is why first 0, this is the only single pixel width here. So 0, 1, then now we have to, this boundary is having 2 pixels now. So, and the direction is 0 direction, that is the east direction. So running in this one, 2 pixels, and that is why it is 0 square. Then 1 pixel which is in direction of south, for south we have given code 3, so the 3 is appearing. Then now 2 more in the direction of east, and east we have given code 0, so 2 square, and then 1, and likewise we continuously keep coding till we reach to end of this pixel. And here, that is why 1 power 3 is shown here, that for this one we are going up to this place. So because for north the code is 1 and the 3 pixel has to be recorded. So now once we reach to this place, the entire boundary, the shaded boundary, is recorded. And this kind of coding or this kind of compression is called chain codes. Otherwise system will, if we don't go for compression using say this compression technique, which is chain codes, then each pixel has to be stored in the image in the system. Now here only these codes are stored, and once these codes are stored, then you can go back and unzip the things or decompress it. So this kind of thing are there. See, there are if you try to understand, there are 2 basic kinds of compression techniques exist. One is called constructive compression techniques, and which are reversible, that means I will explain further. And another type of techniques, compression techniques, which are called destructive compression technique, in which you cannot restore to your original image. And the best example is like JPEG. JPEG is a destructive image compression image format, where if you have lost the original file, like suppose you have taken a photograph or a satellite image which was in .tif format, TIF, that is tagged information file format. Now this format image you have compressed in JPG format and you have deleted the original file. Though the JPG will this is a compressed image format, so it will occupy a very little space compared to your original TIFF file, but the quality will deteriorate. So and if you later on you realize that no, I didn't want to lose the quality, I want to have the original quality image, then you cannot restore back. That is why we put them under destructive image processing technique, image compression technique, whereas TIFF on TIFF also you can apply certain compressions, which we will see the example, and you can decompress it and you reach to the original thing. Like in WinChip, you compress anything, text file, image file, audio file, whatever in your hard disk, and then later on you can decompress it and you don't lose any data. There is no modification or manipulation of your data. So that is why it is more popular. So once people understand, then they will adopt a particular compression technique for their requirement. So first technique the basic type of technique which we have just discussed is chain quotes. Now there is a very popular compression technique which is also called RLE, run length encodes or run length codes. In this one, it allows the points in each mapping unit, and mapping unit is our pixel, to be stored per row in terms of from left to right, and of a begin cell and end cell, because the location of the cell has to be also stored. And this in run length codes, if we want to say the same binary image, if we want to code it, then only these number of rows, and we can in roughly in just 8 rows we can store this entire image rather than 16 by 16 rows and columns. So how in run length code is there, we start with 9, because only on the 9th row we are having the black areas. So 9th or shaded area, so 9, and then run length along the from east to west, from west to east, what is the number of pixels, and that is what is run length. So that 2 pixel second, 2 pixel 3. So these two are coded. Then there is a gap, so the gap is left. Then 6 to 6, that means only 1 pixel has to be coded. And then 8 to 10. And let's go for row 10. Row 10 is continuously having the shade up to this column 10, so it is 1 to 10. Same with the row 11, 1 to 9, and so on and so forth, till you reach to the end, last row, and that last row is 16, and the shaded area which has to be coded starts from column 9 and ends at column 11. So likewise, instead of storing the values for each pixel, we store only, in this example, only 8 rows and length of the shaded area. The third basic type of block code is the compression technique is block codes, and this is a little complicated compared to the first two previous one. That the idea here of run length codes can be extended to 2 dimensions, because run length was just 1 dimension. It starts from a particular row, and then along the from west to east is run the length. But here, instead of having that, we can go for square blocks of tiles, and through which we can cover the area. So what we are seeing here, first the search is made where the largest square block can be used. So in this example, what we are seeing, that a 4x4 block, square block, can be coded here. Then there are many square blocks of 2x2, and then till you keep doing this thing till you reach to the unit level. Unit level here is just 1 pixel. So the rest of the, or we can say black blocks, are just single block. So let's see how the codes will look. The data structure here consists of 3 numbers for each block, that the origin or center, bottom, left of the block, and the radius, means how thick or wide the block is. So 4x4, maybe 2x2, maybe 1x1. And this image can be coded very easily with the locations of block X and Y, definitely. And there are, what we see, that there is only one square having 16 pixels, which is shown here in blue color. Plus there are 9 squares of 4 pixels. that you can see. So 4 pixels squares are there. There are total 9, and then there are 70 unit square. So when you add up with this thing, the entire shaded area or black area has been coded. Of course, you have for each block square you have to store the origin, but instead of storing 16 by 16 pixel image through this compression technique, the same area in this particular binary example, which is very simple one, and only the shaded area can be stored. Now here, more the homogeneity we find, definitely we will achieve more compression, and this is true for all compression techniques. If there is that means if sometimes there are a lot of redundancy which is present in the data, and that the redundancy is nothing but the large homogeneous area present in an image. If the situation is there, then you can achieve very high compression, especially like from black codes. So the larger the square that can be fitted in any given region, and the simpler the boundary, the more efficient block coding becomes. So as homogeneous, because large homogeneous areas, if they are found in an image, you will achieve very high compression. And the fourth basic techniques is called Quadra Trees, and this is little complicated method, but can achieve very high compression. It has been implemented in many digital image processing softwares, and there are various versions of quad trees like oct trees and so on. They too have been implemented. So let's see what is basically quad tree. So quad tree method is more compact representation, therefore it achieves more compression based on the successive division of the 2 power n by 2n array into quadrants. So each area, if it is not homogeneous, then it is divided in 4 quadrants, and this division goes on till you reach to the unit level. Now in this example, we have taken a 16 by 16 pixel binary image. What we are seeing here, that in order to code this shaded area, first this whole image is divided into 4 quadrants, and 4 codes are assigned to each quadrant. For this northwest quadrant, 0 value is assigned. For northeast quadrant, 1 value is assigned. For southwest quadrant, 2 is assigned, and for southeast quadrant, 3 is assigned. Now this coding for different quadrants will continue till you reach to the unit level. A unit level here is our pixel. Now after dividing into 4 quadrants, the search will be made whether we have achieved the homogeneity within the quadrant or not. If yes, then no further divisions will be required, and if no, then further divisions are required. So in case of quadrant 0, quadrant 1, no further divisions are required, because we have reached the homogeneous area. There are no black areas. All pixels are having same value, white value, or 1 value. Rest are maybe 2 other quadrants are having some pixels which are having 0 value. This is because we are taking example of binary image. Now let's go in the quadrant 2, that is the southwest quadrant. Here we find we have not achieved the homogeneity. So now this quadrant 2 will be further divided into 4 quadrants, and the coding scheme will be the same as the done for the first 4 quadrant here. So again the northwest quadrant will get 0, but that would be the second digit, and therefore if you can see here, this is 2 0, and further 0 and 1 how these have come, I will explain little later. So this has been the quadrant 2, the large quadrant 2 has been divided into 4 quadrants, and then again search is made after coding, and if homogeneity has not achieved, then further division is required. So in case of, say, if I take this example of 2 0, the quadrant 2 0, then further divisions are required. Now out of these 4 quadrants, this quadrant will have 2 0 0. Now here and quadrant 2 0 0 still having heterogeneity. So further 4 divisions are required, and now we have reached to unit level, and therefore this quadrant is having 2 0 0 1, whereas this quadrant would have the code 2 0 0 0. And likewise you keep making divisions or divisions in form of quadrants till you reach to the unit level. There might be a question here or a scenario that it is mentioned in this during in this course, duration of this course, that a unit of an image or raster has to be square in shape. But at the same time, it has also been mentioned that the overall shape of an image can be either square or rectangle. So if we remember that one, then all the time all images will not have a square in shape. We can have an image which may be rectangular. Overall shape of the image may be rectangular. So how this then quadri will be applied? So that example we will see little later. And why it is called quadri, that we will see. So now each these things have been coded here, as you can see very well. So once the homogeneity is achieved in any quadrant, no further divisions are required. So quadri, because you divide in 4 quadrants, so it's a nothing but an inverted tree kind of concept. And like here, that 0 1 2 3, it is realized that quadrant 0 1 and 3 have reached homogeneity, no further divisions are required, whereas quadrant 2 requires the division. So then again 4 quadrants, again 2 1, quadrant 2 1 requires further division, so that it has gone to the 3rd stage of division. And this is the example here which I was just mentioning, that it is not necessary that image should have only a square shape, it can have rectangular shape. The example here is, it deliberately it is shown here that the divisions are being made like this. So here also we are sort of square, in this quadrant we are also sort of square, in this quadrant also, and that means the image has to be extended. And this is how we achieve the concept of a square image, which is the prerequisite of your quadri. So we extend the image, or through the software the image is extended, so it becomes a square in shape, and then quadri is formed. So here the example, every block has been coded here 0 1 2 3, and then in the 2 further divisions are required. So on this side it has been extended. So this is the center of that place where divisions. So this is quadrant 1, so that becomes 2 1, and then further division, so it is 2 1 0, and likewise. And you are having quadri levels, first, whether it is first level, second level, third level. This tree is here, the table is shown here, and different types of either here, instead of having binary, now we are having multiple types of units are there, though still it is a schematic kind of image, or a very simple, still very simple example. But in real one also, where you are having various types of ground features present in image, but still quadri can be performed. So quadri might take a lot of time, compressions, but it provides a good compression, and further you can anytime achieve to the original image. So this is completely a destructive, non-destructive image compression technique. As I also mentioned that there are various compression techniques which are associated, which are suited for certain kind of image formats. For example, TIFF. So for TIFF images can be compressed using LZW compression. What is LZW? Basically it was developed by 3 mathematicians, Lempel, Jacob Ziv, and Terry Wells. And these the first character of their names have been taken. So L, J, and W here. So LZW compression, which this file into a smaller file using a table based lookup algorithm which was invented by. This is still a non-destructive image compression technique. So your TIFF file, maybe GIF file, can be compressed using LZW. Very common, have been implemented in various image processing software, and you can reduce the occupancy on your hard disk by a large image, higher spatial resolution image, and many image processing operations can be performed even when your image is compressed with LZW. So that is the another advantage with the LZW. So the two commonly used file formats in which LZW compression can be performed, and many operations, digital image processing, can still be operated without decompressing it, which are the formats which are suitable for LZW compression, as I have mentioned, GIF and TIFF file formats, and this compression is also suitable for compressing text files. Generally, text files do not have much redundancy, but if somebody has created a lot of blank pages in your text file, that means lot of redundancy is available, and therefore you may achieve something. So here is one example from a public domain software which is called Irfan View, and I am showing that a file original file was in TIFF format, and now I can choose the image compression format, which is LZW, and once I choose this one, there are other compression techniques are also available, like RLE, which is nothing but the run length codes or run length encoding. This is the same way, and same technique, run length encode has been implemented. JPEG is there, pack bits is there, and of course our very common compression tool GIF is also there. But as I mentioned, the advantage with LZW compression, that even various image processing operations can be performed on LZW compressed images. So that is the biggest advantage. Now there are JPEG example here, the original image in JPEG. So we are having this options. These options, again, it is shown in through this software Irfan View, that lossless compression. That means you do not lose the quality of image, and therefore there will not be any need for you to keep the original file. So there are possibilities of lossless, and generally the options which we go for JPEG are full of loss. So we lose the quality, but at the same time we achieve a very good compression. So it's a trade-off. You want to have a very compact file size, or you want to have a good quality image. This is very ironic that people are going for higher and higher megapixel mobile cameras, but at the same time they store, or they originally take images, save their images in JPEG format, and JPEG format is not really non-destructive, it is a destructive image format. So in some way the investment which they are making for quality of image, they are not achieving if they are saving their images in JPEG format. Instead they should save, if options are allowed, your operating system allows, then you save it as a TIFF. And you can do this experiment, save the same file in TIFF format, original file, then save as JPEG, and then zoom any common part which is on the both image. You would realize after certain zoom in that there is definitely deterioration of quality in JPEG format. Nothing comes free, it's a trade-off. You achieve a very good compression, but at the same time you lose the quality. But sometimes because of for the transmission requirements through sending through net or making a storage, we go for JPEG as well. So LZW compression algorithms takes each input sequence of bits of a given length, for example 12 bits, and creates an entry in a table, as I mentioned, lookup table kind of thing, or code book for that particular bit pattern, consisting of pattern itself and a sorter code. And the input is read. Any pattern has been read before results in the substitution of the sorter code, effectively compressing the total amount of input to something smaller, and that is why compression is achieved. And there are various versions of LZW are also available. Like LZW, which was developed in 77, then the modified version, upgraded version 78. Then the other one is also LZW algorithm does not include lookup table of codes as part of compressed file, and decoding pattern program that uncompresses the file is able to build the table itself by using the algorithm as it possesses the encoded input. So the decoding or unzip is inbuilt basically. Now this JPEG, which is an ISO group of experts, which is called Joint Photographic Expert Group, have developed, and there are various versions of JPEG are also there, and which is JPEG is also term for any graphic image file produced by using JPEG standard. JPEG file is created by choosing from a range of compression quality. You can choose you want to have a 100% quality or 50% quality, and then accordingly the compression will be performed. And when one creates JPEG or convert an image from another format to JPEG. So JPEG is a compression technique, same time image format as well. And question is asked to specify the quality of image. And since the highest quality results in the largest file, you can make a trade-off between image quality and file size. So you have to assess that whether you want to retain the quality of an image or you want to have a high compression, and accordingly things are chosen. There is another formats which are still popular, which is a GIF format. GIF basically graphic interchange format, but mainly it is used for animations. And there is another format, portable network graphics, which is PNG format. Various format exists. None is universal or none is the best. There are some advantages and there are disadvantages. Like TIFF is good, but it occupies a lot of space. JPEG is good from point of view of hard disk space, but it deteriorates the quality of your image. So these are the common formats on the web. Your JPEG and GIF, and has become de facto standard form of image. GIF uses the 2D raster data type and is encoded in binary. There are two versions of the format, 87A and GIF 89A, and version this allows the possibilities of an animated graphic. So if you are having a sequence of frames, you can put a time gap and can create a sort of movie or animations which are becoming very popular. One example here I am showing, there are 8 images created from different 8 directions for certain purpose to remove a false topographic perception phenomena, and the 8 illumination position of the sun is there, and then all these 8 frames of the same size have been put in a GIF file, and through some utilities like GIF creator and other things, and it becomes a animated file. So single file will have 8 frames with the time gap for changing from one frame to another is depending on the user. How fast you want to change these frames or how slow you want to. That you can choose while building up the GIF file through utilities like GIF creator, and many such things are there. Here also that illumination of the sun is starting from horizon, it goes to overhead. So there are about 10 images for different angles, or rather and then you see they have been put in a sequence with a time gap. Here this is in the previous one it was little slower change in the frame, here it is little faster. So the time between 2 frames change is maybe few seconds, and there it was much larger, and therefore a single file will carry a kind of movie. So these are animated files. This is interchangeable and it's a patent free. So there are no copyright issues and other things. Now this another image format which is very popular for large images, and which is Mr. SID, which is multi-resolution seamless image database. And this compression is really very, very powerful. This has been created by a company which is called Tech, and it can compress a 15 MB file into 1 MB. And this is completely non-destructive image file format, compression technique. However, details are not known because it is copyright protected. So one problem previously associated with images was long amount of time took to open very large files. So what we do, we compress our images and then we can display these images very quickly. And like Google Earth images are having this kind of compression. So when you display even high resolution image, the display is much faster because this compression techniques have been employed there. So the creators of Mr. Sid overcame that problem by giving user the ability to decompress just the portion of the image they wanted. That is why it is called multi-resolution seamless image creation or image database. So as you keep zooming an image, like in Google Earth we keep doing, first we say looking over India, then we keep zoom, and then maybe Uttarakhand, maybe within Uttarakhand, Haridwar district, then Roorkee, IIT. So as keep zooming, we are going higher and higher in that kind of pyramid, and we are seeing multi-resolution images are coming, and they are all have been put in this Mr. Sid format. So another problem associated with massive raster data images was the large amount of storage space they required. Now, as you know that in many change detection studies, some of them we will discuss just for an example here, in maybe in little later in different lectures, that nowadays since 1972 onward, remote sensing data, that is Landsat MSS till the Landsat OLI series of Landsat series data is now available on net. Similarly, other satellite data are also becoming available free of cost on net, and therefore lot of change detection studies are being done, can be done. And in order to do these studies, we have to handle large amount of data, and therefore the requirement of very efficient data compression techniques which should help us for fast display, which should help us to occupy very less space on hard disks. Requirements of such compression techniques has really become huge nowadays because of the handling of data is also very large nowadays because of free availability of data. So people are looking for different. The Mr. Sid is based on the patented wavelet technology, first developed at NRL at Los Alamos, and to achieve a compression ratio of 20:1 for gray images and 50:1 for full color images. So 50 MB image may be compressed into 1 MB image. It depends again on the homogeneity or redundancy in image. So now the satellite image from a space that once required and the storage space of 40 CDs could be compressed with Mr. Sid and stored on only 1 CD. So that kind of compression is there. Another concept which is not exactly compression, but it improves our display of images on a screen through image processing system, and that technique is called Pramod. It has become very popular, and many digital image processing softwares, even GIS softwares, have implemented. Like for example ArcGIS, they too have implemented. So whenever you try to display a raster image first time, it will ask automatically, do you want to create pyramids? And if you say yes, then it will create 2 very small files. These small files are keeping the structure of your pyramid. And this will allow again the same thing, that as you zoom, a higher resolution image will appear. You keep zooming, you get more further and further details. If you zoom out, then you see lower and lower resolution. So this Pramod allows a very good, this is a very good facility which is now available in many popular image processing and GIS software. So Pramods are reduced resolution representations of data sets and are used to improve performance in the display. And pyramids can speed up display of raster data by retrieving only the data at a specified resolution. If I am looking in the middle of that thing, that means in the pyramid I am the middle, I will see only the middle resolution image, not a high resolution image at middle stage. So the coarsest level of resolution is used to quickly draw the entire data set on the display. As the display zooms in, layers with finer resolutions are drawn. Pyramids are used to improve performance because ultimately we want to quickly see the image, and this is how it is done, that at different scales are also shown here, different resolution image of the same area is shown. And once you opt to construct a pyramid, then this is how the pyramid is constructed. So pyramids are used to improve performance. These are downsampled version of original raster data set. So at this scale you are having downsampled. That means that it is subsampled data. So only the coarse resolution image will first appear when you are looking for a large area. So that is why it is original raster data set and can contain many downsampled layers, and each successive layer of the pyramid is downsampled to the scale of 2:1. With pyramids, a lower resolution copy of the data displays quickly when drawing the entire data set. And as you zoom in, the finer resolutions are drawn. Performance is maintained because you are drawing successively a smaller area. So you are zooming in, you are reducing the you are covering the less area but higher spatial resolution. So the database server chooses the most appropriate pyramid level automatically based on the user's display scale. So as you zoom in, the scale is becoming larger and high resolution data is being displayed. Without pyramids, the entire data set must be read from the hard disk and resampled to a smaller size, and therefore lot of time is taken. So pyramid is good for making your display much faster. So this is called display resampling and occurs when the software displays refresh. So whenever any such softwares ask you first time when you are displaying an image, would you like to construct a pyramid, you say yes. It will take few seconds to construct the pyramid, and it will keep two separate files along with the same name but different extensions of the image. And then next time whenever you will display the image, your display would be much faster than the original image. So pyramids only need to build once, as I have mentioned, per raster data set at the very first display time. After that they are accessed each time the raster data set is viewed. Here this word raster instead of image because you can also apply on your digital elevation models. So in digital image processing we are mainly focusing on remote sensing data. So instead of raster you can say the image data sets, and the larger the image data set, the longer it takes to create the set of pyramid. Of course, if a file is very large, it will take few more extra seconds, but it doesn't take much time. This means you will save more time in long run. So next time when you will open a image file, a large image file, you will get a message on your screen, would you like to create a pyramid? If you choose yes, then some options are also there. Even if you go for default, there is no harm, still it will your display will become faster, because these resampling techniques, nearest neighbor, bilinear and cubic convolution, are the same resampling techniques which we have discussed while discussing the last and third step of your georeferencing. So the same resampling techniques have been employed here as well. And this brings to end of this raster data compression techniques. 4 basic compression techniques we have discussed. There are various other compression techniques. Details of some of them are not known, like your Mr. SID format, which is copyright protected, though we know that it is based on wavelet concept. And there are other approaches like pyramids, which we have seen that how advantageous it becomes for displaying the large images. So depending on your requirements, and one should choose, but whenever you are choosing a image format, my suggestion as per my experience would be choose that image format which is non-destructive, so that anytime if you want to restore the quality of original quality of the image, you should be able to do it without much problem. Thank you very much.